The last thing we're going to talk about is actually describing the size of a set with proper notation. So when we looked at some of those sets earlier, like the set of natural numbers from 5 to 9, 5, 6, 7, 8, 9, count them up, you got 5 things. And it'd be nice if we had a faster way of saying that, if we had a nice compact way of saying that, and that's where we get the idea of cardinality, or the cardinal number. So, for some set A, the cardinal number of A or if you prefer, cardinality is generally how I refer to this. I say cardinality, but cardinal number refers to the exact same thing. Is its number of elements. And it is denoted NA in parentheses. So this says right here, and let's give it a value. I don't know, let's say the value there is M. So as a sentence, this is read as cardinality of A is M. Fairly straightforward. So let's think about this in the context of an example. Let's say we have the two sets where our sets are the set of states whose first letter, the set of states beginning with the letter A, and the odd natural numbers less than 8. So if we wanted to write those sets out, we would get A is equal to Alabama, Alaska, Arizona, and Arkansas, so I believe it is AR, ran out of space, while the set O, the set of odd natural numbers less than 8, is 1, 3, 5, and 7. And I'll write those in a weird order just to remind ourselves that it doesn't really matter what order they have, how we arrange them. So, if we want to talk about the cardinalities of each, we could just say N of A, out of myself, is 1, 2, 3, 4. Cardinality of the set A is 4. And in this case, cardinality of O is also 4. And it certainly would be nice if there was a way to talk about two sets having the same number of elements. And there is, with this, because they have the same number of elements, we can say that the sets A and O are equivalent. As the cardinalities are the same. Cardinality of A equals the cardinality of O. The definition for equivalent sets is sets with the same cardinal number. The other way we can talk about that, the more meaningful way that we can talk about that, but it doesn't matter quite as much to us, is to say that there is what's called a one-to-one correspondence between them. I guess that's where the name has a bit more meaning. What that means essentially is we can attach each item in one set to one of the other. So we could say that Alabama goes to 3, Alaska goes to 1, Arizona goes to 5, and Arkansas goes to 7, or scramble that order however you want. But the idea is you could set one to the other and not have anyone unrepresented, or have one thing going to multiple places, or multiple things going to the same place. That's the same way as saying there's a one-to-one correspondence, but meaningfully, simply, that means they have the same size, same cardinality. But very clearly, these are not the same. And from there, we get our next definition, which is the idea of an equal set, where we say that our sets A and B are equal, noted in exactly the way you'd expect. A equals B, if they have the same elements. So that's where this idea of reordering comes in. That's another way of looking at the idea that 1, 3, 7, 5 is the same as 1, 3, 5, 7 is the same as 3, 1, 5, 7. That O is O is O is O. No matter how we choose to write it. Order does not change anything. These sets are still equal, but these sets are very clearly not. So one thing that's important to bear in mind in connection between these two properties, sets that are equal are always equivalent, but sets that are equivalent are not always, and in fact more often than not equal.